Here we go. What's a midpoint? Another definition for today. Nancy? Okay, but what does it mean to be in the middle? Good. Can you incorporate that two sides equal into your definition? Somebody else?
A point that lies on a line segment or a line that
Wait, which one? A line or a line segment?
segment
Okay.
that rests on a line segment that is the same distance from one endpoint that it is from the other endpoint.
Works for me. Is that what you said? Yeah. Okay. So staying with using specific letters here in this case, we end up with a definition where we have the point being the midpoint has to be that special point. So we talked about yesterday all these different points being between the two endpoints. So in this case we have P and Q. We have an infinite number of points that are between P and Q. We argued about that for like 20 minutes yesterday. Now today we're going to say, okay, we don't want any one of those points. We want one specific point that's exactly in the middle, that's equidistance from the two endpoints, and we're going to call that thing a midpoint. So there's an example. Little bit of review there from yesterday. Notice we've got some monitor that's not working correctly. There you go. We got some tick marks here. So the tick marks are representing congruent distances, so we know that PM is congruent to MQ from the picture, which makes M the midpoint. It's got to be on the segment though. Blah, 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 blah. But does that look familiar? You should know that, right? Midpoint formula? Average of the x's, average of the y's. So if you're on a coordinate plane now, so instead of talking about any segment anywhere, any midpoint anywhere, we're going to put it on a coordinate plane where we've got the point A being at x1, y1, and the point B being at x2, y2. And then if we want to find the midpoint, we take the average of the x's, average of the y's. What's an average?
All the numbers added up and then divided by how many there are.
Right, so since we have two x coordinates, add up the x coordinates divided by 2, add up the y coordinates divided by 2. Okay, so we'll start with something easy. Find the midpoint of the segment ST. When you get an answer, check with your neighbor to see if he or she has the same answer. If not, figure out who made a mistake. That's yesterday's slide. we doing? Since it doesn't specify, you could answer in decimals or you could answer in fractions. It's up to you. We good? I don't remember. Jenna, what do you got?
I got negative 5.5 and negative 3.5.
How'd she do? Good? Or negative 11 halves and negative 7 halves if you left it in fraction form? Okay, how'd you set that up?
So I did 3 and plus negative 14
Mm-hmm.
over 2.
Good?
And I did 2 plus negative 9 over 2.
Good? Then you did some math. Use your calculator? No, you just like the decimals better? Okay, good. In this case, it doesn't matter which one, either fractional form or decimal form. Okay. Sometimes it'll specify in the problem which one to use, other times it won't. So if it doesn't specify, you can give either answer. All right, now let's ramp it up a little bit. Read the problem first, draw a picture of what's going on, and then we'll attack it. How is problem 2 different than problem 1? Max?
The midpoint is shown in this one, and the endpoint is missing this time.
Okay, good. First one we had the 2 endpoints, we had to find the midpoint. This one I gave you an endpoint and a midpoint, and you have to find the other endpoint. Max, which one is which? So if I draw a segment here, how do I label these 3 points?
The one in the middle is M,
Okay?
and I guess, well, I guess either one could be K,
Which one? It's your choice.
the left one.
We know that K is at 1, 2. We know that M is at 5, negative 6. Max, what do you want to call L? The coordinates of L.
Not sure.
Well, there's no wrong answer, just what do you want to call those 2 things?
X, Y.
We could use X and Y, we could use A and B, we could use whatever you want. Now what? Not just Max, anybody, what do I do now? How did we do problem 1? Jordan?
Should you find the use the midpoint formula, but then divide that by what you got by 2?
Okay, so can you help me set up the midpoint formula then, for this particular problem?
M equals 5 plus 1 divided by 2.
No, because that will give me the midpoint of Km. You're on the right track, you just set it up wrong. Other ideas? Anybody else? How do you find the midpoint? Max?
Well, wait, hold on. No, I
let me get caught up. And what does that have to equal? And yeah. Nope.
5.
Daniel? No,
Yeah.
it is Daniel. 5. Why?
Because the x-coordinate for m is 5.
Good. Okay, so when we did the previous problem, we took these two x-coordinates, we added them up and divided by 2. And the answer that we got was the x-coordinate of the midpoint. In this problem, I know one of the x-coordinates of the endpoint. I know the x-coordinate of the other endpoint. We just called it x. And when I add those up and divide by 2, I should get the x-coordinate of the midpoint, which I already know. So we get 1 plus x divided by 2 equals 5. How do I solve that? Go.
Multiply both sides by 2.
I got half of my answer now. Mary, back to you. What equation do I set up for the y value now?
2, the whole thing?
Yep.
2 plus x over 2 equals -6.
Close.
In parentheses.
No, you said the wrong thing. Give it to me again. Because we're finding the y coordinate of the midpoint, or the endpoint. You said 2 plus x over 2. What should it be? Yeah, because we're looking for the y value now. Therefore, L is located at 9, comma, -14. The difference between 1 and 2, obviously it's a completely different problem, but in problem number 1, we kind of set up one equation. In other words, we found the midpoint right away. In problem number 2, you need to set up two different equations. Okay, one to find the x value down here, and one to find the y value up here. Got it? Yes, sir.
Can't you also just find the slope and then solve that way?
Oh, interesting. Do tell.
And so from k to m, the x-coordinate goes up by 4, and the y-coordinate goes down by 8.
Wait, hold on. This could be important.
Okay.
Okay, so going from k to m for the x coordinate, it went up 4.
Yes.
So your argument, let's just focus on the x for a second. Your argument is then what?
It'll go up by 4 again. So it'll.
Which it did.
Yeah. And then at the y-coordinate, it goes down by 8.
Whoops, which it did. Will that always work?
If it's the midpoint, yeah.
Do you agree?
Yeah.
Let's test it, shall we? What did we have for an answer for number 1? We had negative 5.5 and negative 3.5?
Yeah.
Okay, so Daniel, if what you're saying is correct, to go from 3 to 5.5 is a change of how much?
About 8.5.
Okay, so then if I take negative 5.5 minus 8.5,
Yeah, that's,
is that negative 14?
yes.
Okay. To go from 2 to 3.5 is down by
5.5.
5.5, and negative 3.5 minus 5.5. Ooh, fancy. Nice. Okay, so now we got two different techniques to find that, or to solve, I should say, problem number 2. If you know an endpoint and a midpoint, you can use the slope to figure out each of the x values by how much it changes going from the endpoint to the midpoint. Sometimes it'll change positively, sometimes it'll change negatively. What's important is that you understand one of these two processes. Any questions on these? Can you handle one of them? We're good? Beautiful, thanks. Okay. Last one. Again, draw pictures so you can see where the midpoint is. Label your known distances. Solve. All right, let's stop for a second. How many people have the diagram drawn? Raise your hand. Good. For those of you that have the diagram drawn, how many of you don't know where to proceed? Okay. How many of you have a final answer? Okay, so we're gonna need to work together a little bit. Let's see. Can you go up to the board? You got your diagram?
Yeah.
Good. Can you draw your diagram up?
Nope. How do you erase?
See the little circle? No, down more. The open circle. Yeah. Click on that. It's a big honking eraser though. And then click on the color you want again. Okay. And your distances?
I don't think I have that.
All right. We'll pass it on to somebody else. Who has the distances? Go. So get a visual representation of the situation first, then we'll see if we can do the algebra together. Question?
No, I was gonna say what I did.
Okay, hold on. Good. Stay up there for a second, just to make you uncomfortable. What else do we know?
Well, the other side, EO has to be 6 minus 3 after 2.
Why?
Well, because, equal distance part.
Perfect. Can you label that for us, Jerome? Hear what she said?
Yep.
Beautiful. Now that we get that chunk of information, we should be able to set up an algebraic equation. decaf the pen and put it in the tray there for me. So I'll give you a couple of minutes there to figure out what kind of what kind of algebraic equation you can set up, and then solve it. Remembering what we did yesterday. Okay, we got it? Everybody has it, yes or no? Anybody not have it? Okay. If you don't have it, then either wait a second or ask your neighbor to see what equation you should set up. Good, now solve. Okay. Or you just sat there? Okay. He wants to know.
Negative side is 6 3x plus 6 minus 3x equals 14x plus 2, and I got on from there.
Beautiful. Okay, we good? So we want to talk about a couple things now. The first thing is the fact that on day one, maybe not day one, maybe day two, I talked about how the learning progresses and that it's important. This is a problem just like what we did yesterday. What's the difference between this problem and what we did yesterday? Well, let me ask two questions. What's the difference and what are the similarities between this and the algebraic problems we did yesterday? Yeah.
Yesterday, it didn't have a midpoint, so it can be different amounts on each side.
Okay.
Just something in the middle.
Okay.
And then similarity, so you still have to figure out half of it that gives you the answer for the other half because you know the entire thing.
Okay. Let's talk about three different ways to solve this problem. Okay. I had two, and then Max brought up something that I thought was interesting that we'll talk about. What did you do, and/or what equation did you set up? Tell me your name. I'm sorry.
Nicole,
Nicole, what'd you do?
I did 6 minus 3x plus 6 minus 3x equals 14x plus 2.
Okay, so let's suppose we didn't know that O was the midpoint. this was yesterday. Would that equation work with the stuff we did yesterday?
Yes.
Yeah, because we're taking these two little parts, adding them up and getting the big part. And then you solved this, blah, 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 did a bunch of math, and what did you get for x?
I got 0.5.
0.5, are we okay with 0.5?
Yeah.
Okay, 0.5, good. Then plug it back in, find the answer. Okay, very good. That's one way to do it. Anybody do it other than Max, because we'll get to him in a second. Anybody else do it differently? Okay.
You can take half of 14x plus 2 and then make it equal to 6 minus 3.
Okay. Let me change colors here. I can take half of 14x plus 2 and set it equal to 6 minus 3x. Why?
Because 6 minus 3x is half of 14x plus 2.
Okay. And along the same lines, kind of a method 2.5, we could also do 2 times 6 minus 3x and set it equal to 14x plus 2. Same answer? Beautiful. That's 2. Okay? All right, Max, you're up. What did you do?
So I took 14x plus 2 and subtracted it by 6 minus 3x, or I wrote it as negative 3x plus 6.
Okay, so what he did is he didn't realize or didn't use the fact that this distance PO would be the same as this distance OR. So he went and found this distance by taking the big distance minus the little distance. Does that make sense? 14x plus 2 minus parentheses 6 minus 3x gave him a value of,
17x minus 4.
and he said to me, this problem can't work because that needs to be 6 minus 3x. So after he did the algebra, he realized that this value, which he just found to be that distance, didn't match that value. Which seems like a valid question until, yes, Max?
But they actually do match. So if you take 17x minus 4 is equal to 6 minus 3x, and then you do the math, just do plus 3x on each side, you eventually end up getting 20x is equal to 10, and then gives you x is equal to 1/2. And when you plug that into each x, it gives you 4.5 and 4.5 on both PO and OR, and 9 on the entire thing.
Good. Okay. So we got a whole bunch of stuff going on here. We've got 2 equal halves added together to equal the big half. Or big, I shouldn't say half, the big segment. Okay. Which is again the same technique that we could use yesterday. Or we take the big segment, chop it in half, and get the little half. Take the little half, double it to get the big half, or take an algebraic approach like Max did, subtract these two, this minus this must be that, and then set these two equal because they have to be equal because of a midpoint. 3 different ways to solve the same problem. Good? So I did it by doubling. Oh, and I didn't finish the problem. So I got the value of x being 0.5, and then as it says, we want to find PO, so plug it back in and find that distance of 4.5. What's bisector? What does bi mean? 2. What does sect mean? I'm sorry?
Part?
No.
Portion?
Close enough. And to cut. To break into 2 pieces. So a bisector is something that divides something in half. And the reason we waited for today is to talk about this instead of yesterday is because a bisector will split something into two equal parts, and that's the important thing. It's gotta split it into two equal parts. We already talked about one bisector, and that's a midpoint, but if we expand that past a midpoint, we can get something like this. So here's what we've already talked about. In this case, the midpoint is the bisector. It's the thing that's chopping that segment in half. We can expand on that though, and instead of just using a point, we can use a line. So now this line is bisecting the segment. Or we can even expand it into 2 dimensions and split it with a plane. Okay, so now the plane is bisecting the segment. And notice, each one of those, it's a segment that's being bisected. Why doesn't it make any sense to say I bisected a line? Name again.
Kevin,
Kevin, what do you got?
because a line is infinite, so you can't really cut it into half.
Correct. So all these are bisectors of segments. Just a little bit more terminology for you. We're done. Okay. Didn't seem like a very big slideshow, but there